Okay, my friends, before we get started, I just want to tell you, this is about a dispute between Don Lincoln and myself. He's with Fermilab. He's the director of communications, basically. If you want to talk to them, you have to talk to Don. And I reached out to him about his particles here. And I said, I think we might have found your particles, Don. Would you please take a look at this? He always ends with, what I want a phrase defined, have a question. So I did. I reached out to him, and this goes back a very long time ago, approximately 10 years ago. And these were the two particles, and I believe we did find them. And here they are right here. Here's his particles. He says there's a black one with a glowy edge around it. And then there's one that has no mass to speak of at all. And that's exactly what we found. The black one with the glowy edge. And here, and then the glowy one that doesn't have any mass. It can get big and get small. And what we did was we put it into a venturi, which is a restriction. And it's so tight that the black couldn't get through, but the white could squirt through. And that's exactly what did happen. And here's the venturi. Right here. The light came through here, and normally it's just a wave. And they always say it's like a wave or a particle. Well, it's a wave, but that particle right there is inside the wave. And now the particle is coming out here. And right here is where it concusses and it turns into the photon, which is this. All right, and we can see this using CMOS. And this is fully understood now. It's not a mystery anymore. And so what did happen at the venturi? We started with this particle here that was glued together very tightly. It's a photon. Photons bounce. When they hit something, they bounce back at you. If you just had this right here, that's an electron. Electrons are understood to burn, and they're light and so forth. Now, well, light is a photon, but all it is two electrons back to back. They never realized, nobody's ever realized there was a black particle attached to the electron, which gives it's a carrier. And they were talking about carrier bosons for a long time. I don't know, all of a sudden that just went away. But this is the boson, let's call it, which is dark matter. It literally is dark matter. And it attracts anything with white matter, anything that has white matter. Other than that, they can jump right on top of each other, the black ones. They don't care about touching each other. But the white ones hate each other. So when it comes to the venturi, here, the black ones just backed off. You see, the black ones just backed off, and they squirted all the white ones through, and then the black ones jumped back in again. They didn't jump over here, so there has to be extra black ones, I think, laying around somewhere, because these white ones were all by themselves, no question whatsoever. That's just brilliant white. And the black are on their own, no question about that either. And the only reason we can see them is they're on top of the white. Dark matter doesn't reflect, it doesn't absorb, and it doesn't emit, but it will obstruct. But you can only make it obstruct if you can make it disassemble from the photon, which is exactly what we did. This is fission, that's fusion. This is raw electricity. As far as I'm concerned, that's my statement right at this moment. And this is what, you know, I know it's an invasion of territory. I'm sorry for that, but this is what we need, something to help resolve our issues. So I'm going to tell you this whole story because it's very interesting, actually. And I'll try not to be too critical, but it's going to get a little critical. So here we go. Now, I think I showed you, or I will show you, that the increase in energy from the photons from the low energy showers down here to the high energy electron showers. These are high energy electron showers. High energy electron showers. Now, these are the muons. They don't go through, they back off. Now, this is Lawrence Livermore, I believe. And again, this is what we did here. The black ones back off, the white ones shower up. And that's what we did here. The black ones back off, and the white ones shower like crazy. I showed a bazillion times. And this is what upsets me, because we should be able to get free energy and be able to carry it around in something like this, if it works. But it's something very simple to test out. No matter what I do, I'm going to be ignored, so I'm not going to do anymore. After 10 years being ignored, somebody's going to have to step up. That's all it is. I can't do this anymore. I cannot continue on doing this. I have showed that we created the electron showers. That is no question whatsoever, 100% certainty. Zero question that that's wrong. We created fission, 100% certainty. They came back together here. That's fusion, 100% certainty. This is dark matter. As far as I'm concerned, 100% certainty. They are the muons and they are sterile, 100% certainty. These are the electron showers, and that is all by itself creating these extremely high energy showers. That is also extremely certain because luminosity equates to energy. You know, the higher the luminosity, the higher the energy. And they show here, we're getting a higher luminosity, creating extremely things. And this electron flood theory is, dipole electron flood theory is my theory. I've had it for many, many years. And now I can prove it. And it's still, proof means nothing anymore. Nobody will talk because they're afraid to speak up and it might endanger their jobs. But here we need this energy of these neutrinos, a few hundred gigavolts, electron volts, that's billions, to a few trillions. They come in at millions. That's an absolutely incredible increase. Why can't we take advantage of this, or at least try? You know, I say, oh, why don't you just go ahead and do it? Why don't you just go ahead and do it? No, I'm not going to go ahead and do it. Somebody should take the interest in this, the people that we've been paying to try to do this for us. And these are the ones that refuse, and it's Don Lincoln specifically. All right, I'm laying this on his doorstep. And he knows, I told him, I said, if you don't start talking to me, I'm going to ask for a congressional investigation, and that's what I am asking for. Okay, my friends, this is going to be kind of interesting. It's a little bit of a dispute that I've been having with Fermilab, Don Lincoln, who is the science communicator. He's a senior researcher, and he's basically the interface that you have to go to get anybody to pay any attention at Fermilab. And we don't get along, and he has blocked me and told me never to talk to him, and I'm a tinfoil hat guy and an embarrassment to science and all this kind of stuff. Well, I'm going to tell you a little story about going back about 10 years and how this all happened between Don and I. And it gets very, very interesting, I'm telling you. Because, you know, I don't give up easily. And he just wanted to make a statement and say, go away. I made my statement. I said, no, I'm going to ask you some questions about that statement, and I expect you to respond. He said, right at the bottom of this, every one of them, he says, want a phrase defined, have a question? I did. And every time I sent him a question, he just, you know, didn't respond really. And then he said, I'm not going to respond to you ever. I'm not going to respond to anything you say. And I said, well, you know, it's a public agency. You know, you guys are publicly funded. You should do something here. You should at least look into. So I'm not asking you to look into some spooky thing that I don't have any evidence for. I have so much evidence, it's crazy. And I have the evidence of his exact same particles. These two particles right here. These are the smallest particles they can find. The black one has a glowy edge and all the weight. This one is the colored one has no mass to speak of and all the energy. And we found those, and I reported on those. And here they are. Here's Don's stuff, and here's ours. You see this? That's the black one with the glowy edge around it. Exactly what he says, and it has all the mass. And that's the glowy one, it has no mass, it can get small and big, and that's exactly what happened here. There's the black one with the glowy edge, same thing here. These are dipoles. This is my dipole electron flood theory, which means that everything there is, when we always thought there was just one particle that was an electron, it's not, it's a dipole. We always thought it was just that right there. And it glowed, and it had energy, and it could burn, and it could drive engines and motors and all that stuff. Well, it was additionally part of the dark matter. This is the dark matter they've always been looking for. This is what's got Don in such a tizzy. I found all these things for almost nothing. And I know it's an invasion into his territory, but if he worked with me or even just looked at what I had to say rather than shut me down immediately and dismiss me, very arrogantly, I might say. And he said he's publicly funded. That's a public servant. That's not somebody that just says I can do whatever I want. I think it's obligatory for him to examine evidence. This is evidence. This is not nothing. And in addition to that, we were able to separate this, and I think we can get free energy. You see this? They're always looking for electron showers. They say it increases the energy level thousands and thousands of times. Now, if that's true, and I think it is, this is electron showers. Now let's take a closer look at this. But Don is standing in the way of this, and somehow we got to get past that. And I can't get past him, and you're not going to be able to either. The only way we're going to be able to get past Don, who they control the research. Let's be honest. They control the research. Whatever they say, let's fund this, let's fund that, let's research this. I can't do this research. I don't have the money. The guy that did all of the light research with me, he spent thousands of hours. He's burnt out, I think, and gone. I hope he's okay. He just won't respond anymore. And it's Rod Warren, and he's the one that came up with this original design of the Venturi. And he worked with me for 5 years minimum, 6 years maybe at least, and did all of this stuff which I'm showing you. And everything I asked, he did. Everything I said, can you try this? Can you do this? Can you try it? And then, you don't get something where after 5 years you just, it's just common sense. I don't have, that doesn't work for me. I just keep going. If I would, not to say that Rod gave up. He did everything. He's at the end. What do you do after you got at the end? That's what Don is at the end. He should have said, look, I found the particles. Roger confirmed, which is all I was trying to do. My original reach out to him was to confirm, hey, Don, I found your particles. We used light. We didn't use protons. And we could actually see your exact particles because we're way down in that range. We didn't have to split up protons and look through a bunch of stuff. We could see the actual light and particles, which I have shown you. And here they are again. And it's not only the green ones, well, the green ones, the red ones, the blue ones, they're all the same. And there's what they are. That's what a photon is. They're back-to-back dipoles. And here's the red ones. And back here, they're in the neutrino phase. What that means is they haven't built up enough energy to be called a photon yet. And they are building it up, building it up, building it up. And just before they hit the Venturi, they turn into photons. All right, and there's the photons right there. The red ones, the green ones, the blue ones, they're all the same. And again, we can speed up light and we can slow it down. And I think, I'm not 100% sure of this, one way or the other, but I can see the red coming through here and the green coming through at the same time. Now, the green concusses way out here. It's much more energetic. I know that for a fact. Is it going faster than the red? It might be, because I think every time they measure light, it's always like, I think white light. White light contains all the light. So is this going as fast as the green? I don't know. The blue, they look like they're going faster. Let me put it that way. Who knows? But it's no question, it's spinning faster. And light spins. It doesn't flap like a wave. This is the way light does it. It spins like this. Now, if you looked at that sideways, that does look like a wave. Like it's flapping like this, but it's not. It's spinning like this, and that I can prove as well. Rodney did so much work on this. It's a disgrace to not look at this. And anyway, the light spins, and then again, I can prove that. And this red spins much faster. The red spins much slower than the green. The green just pushes it out of the way, and you can see the brilliance. Anytime you see a bright light, it's more energy. The green has more energy. It's as simple as that. And that's not unknown. They know that. This is not unknown. And this red is tumbling this way. Now, this particular shots were done by, I think Fabien Brulé did these, well, I'm sure of it. And I think he's in France. And again, he worked back and forth, and that's the last I ever heard from him after he did a bunch of things like, can you try this, can you try that? And he did. But, you know, you can only ask people to do so much for nothing and waste all their time. And most people were calling us crazy to boot. That's the problem. You can get involved in something, but once everybody pushes back at you and calls you a nutcase, you're crazy, you can't do that, you can't do this, you can't do that. Well, you just keep going, or you figure, what the hell, this is crazy, I'm going to just... And most people do that. They say, it's not worth the hassle. Well, it's just a hassle, and it is a hassle. But this is incredible stuff. Now, he had a different cell phone. You see the photons he was getting? Same photon, but it's pixelated different. Rodney and I have the Samsung Galaxy S3. And look at the particles Rodney gets. Remember, that's the green. They're all boxed in like that. Look at the ones Rodney is seeing. I worked with a different thing. I worked with grids, like mesh, almost like wire meshes and stuff, like to see if... I really didn't do much, I got to be honest with you. Rod did virtually everything. And again, I haven't heard from him. I can't get through to him. He doesn't respond. I don't know if he's okay. I don't know what happened to him. But I do know that you can only do this stuff for so long with somebody trying to crush you down. That's exactly what happened. So we're going to look into this. But, you know, as far as I'm concerned, those are the particles that Don Lincoln found in his article. These are the particles, the same ones. Only we use light so we can see them much better. They use something like this, two of them head on, boom, and then they get a whole batch of stuff, and they might be able to finally find the little parts that we started with, so we don't have to look through all that stuff. That's the key. I'm sorry to keep going on about this, but I'm not going to let up until Don either gets out of the way or says, let's look into this. Because he's the guy, you know, that's where the research is done. I can't do this research. I don't have anybody that's going to step up and do this. I don't have the money. I don't have the tooling. You know, Rodney did all that stuff. Now, I don't know, he must have, I don't know exactly, I do know what he did, the design of the Venturi and all that. It's very simple. But the amount of time he put into this, I can't even imagine. So, I don't think it's going to be like instantaneous you can do this, but I think with the design and keep working it and the distances and the Venturi width and the curvature and the, you know, the different laser and the distances back here and out here and, you know, how you're going to take the pictures, you know, there's a lot of details. But it's I'm showing you it's been done. It's not like it can't be done. It's done. It's done. We need to have the resources of the people that are supposed to be looking for this exact result. And Lawrence Livermore is as well. I contacted them, same result, nothing. But Lawrence Livermore at least appears to be getting close. They're talking about the muons and the electron neutrinos and how they separated them. And the muons stayed on this side and the electron showers came out the other side. Now, what they're using, I think they're using some kind of heavy atoms. We're using light. We started with light. Much, much better. Much better. All right, so we know protons are made out of something. Well, light is the smallest particle there is, and light makes up protons, makes up neutrons, makes up everything. We are made of light, literally. It's the two particles, the black and the white one. Now, my theory is here, dipole electron flood theory. And this is what a proton looks like. All the black matter goes right to the center, and all the white matter surrounds it. That's why they've never seen a black matter, because it's inside. It's always, whatever you shoot against there, it's going to bounce back at you. Because these are the ones that bounce. These don't bounce, they absorb. That's gravity, and it's dark matter. The Earth has to be saturated with dark matter because all light slams into Earth like lightning, static, anything that has these particles in excess, pew, straight to Earth. Now, and I asked Don a whole batch of questions that he just refused to answer because he didn't have the answers. I had the answers, and that's what upset him. And then he just said, no more. I'm not going to, he calls it whack-a-mole. I said, all I'm doing is asking a question. I said, what is light? He went on so many things. Well, it didn't go on that many because he just never answered. It was like a blip done, glip done. That's not right. That's not right. You're wrong. So one of them was about heat. I said, can you explain heat? And he said, it's particle shaking. I said, can you explain why heat adds weight? And I don't think he knew that, but he did eventually because he said, I don't have to answer any of your questions. I'm not going to answer anything you ever asked me. But if you take something and heat it up, it gets heavier. It doesn't get lighter. Only the gases get lighter because they expand. This is the same size. You add electrons to it because it goes harder against the Earth. It's pulled more in its gravity because you saturate it with electrons. That's what makes it warm. It gets hotter and hotter and hotter the more electrons you heat it up with. And then they'll just flow back out again. It'll go back down to the normal temperature. When everything's the same temperature, the weights will be correct. And I know this for a fact because I worked with weights and measures to have my weights calibrated to adjust scales of, merchandise scales in our supermarkets and stuff. We had to go in and calibrate them every, a year or two, I forget now. But you had to put a weight on there, and it had to be calibrated as the correct weight. And the only way they could calibrate it, you had to leave the weights for 24 hours so that they had the exact same temperature of everything else in the room. And they didn't know why either. I said, well, why is that? And he says, nobody knows. He said, but if they're not the right way, if they're not at the same temperature, they're not going to weigh right. And I was like, oh, come on. I said, so I really questioned him. I remember this because I said, that can't be right. And he said, well, it is. That's just the way it works. I said, no, explain it to me. Tell me why. He said, nobody knows. I said, there's got to be a reason. And he said, well, some people think it's because the temperature, when you have a cold object, literally the cold falls off it. I'm not kidding you. You take something, you can see the cold just falls off it. And he says they think maybe it's the temperature's just falling away and pushing it up, or I don't know what he's thinking. But we never resolved it. I just said that's crazy, but you had to leave them there. Weights and measures, you can't just, because I didn't want to have to come back. That's the whole key. Okay, let me just make a point. This whole mission here is to determine what is a neutrino, what's it made out of, what does it look like, what is the particle. I told you what she says about neutrinos. Now, what is a neutrino made of? Okay, this is what they say. A neutrino is a particle, one of the fundamental particles, which means it isn't made of any smaller pieces. It's the tiniest thing that they know of. At least that's what we know of. Neutrinos are members of the same group as most famous fundamental particles, the electrons. They are the electrons, which is powering this device right now. This is also Fermilab. That's what they say. They're fundamental particles, and they can't be broken down into anything else, and they are basically electrons. They're dipoles, and they are electrons. They just don't realize it. This, again, is Don Lincoln, and this is a Dirac neutrino, and he shows a black one, and they're calling it antimatter, and this one they're calling matter. It's really the opposite. The antimatter black they're showing is actually what makes matter up. This is what makes up energy. So there's matter and energy are one and the same as a dipole. This is a neutrino, Dirac neutrino. This is from Fermilab, same guy, Don Lincoln. So I know I showed you his claims from 2013 about the black particle with the glowy edge and the white, well, it's in this case it's red because they see it as red, but this red, blue, and green basically is what we see because we're working with 3 different lasers. Now, So that's his statements about these. And he's still talking about the observer effect because they weren't using CMOS then. Now I think they've changed. He's talking about the quantum foam, which space is filled with particles. Yes, I agree with that 100%. And he says that the black particles are fixed, they never change, but they have a fuzzy edge. And the point-like particles, which is the abstraction, they're abstractions. They're zero size, but they have a field. Now, I can't disagree with those two statements. That has all the weight, and it never changes size. That one there turns into showers when we put it through the Venturi, because it can get small and it can get big, and it's the only one that can squirt through the Venturi. Let me show you. Now, this is when I contacted Don. I saw his particles. I said, Don, I think we found them using light in a Venturi, which forces the fields to smash together sideways. It's better than trying to hit them head on. When they try to hit them head on, they go like this, and they go like this. Almost never do they hit like this. They send 25 billion particles, something like that, and they're happy if they can hit 15 or 20 of them to get collisions. Most of them just go around each other because the fields bounce. They're just like bouncing. And occasionally they just whack them, and then they get all these particles they call a zoo. And it is, because these particles are actually just like this. So when they hit, they get everywhere. We use light. We started with these, so we don't have to see all this mess to dig through. Now, what happens when our particles of light, and they said this is light, and it's made of those two particles, yes, these are the most elementary particles, no question, I agree. When it came through in here and accelerated, and the particle showed up, and then split right here, this is called the muon and electron neutrino. Muon neutrino, electron neutrino. That is the particle that was this particle right here. Now, two of them back to back becomes a photon. If you were just looking for a particle to exist on its own, creating this is what you're going to see. And we did. We broke it apart. We did exactly what they were looking for. And if you can create electron showers, they claim you can get free energy. That's not my claim. That's the claim of, well, let me show you what they do say. I don't want to make any rash claims, but the claim is that you increase the energy potential enormously. Let me just show you that. But this is what we did. We created electron showers here. All the white is electron showers. The muons backed off because they can't get through. They're the big chunks of boom, boom, boom. And the beauty of this thing is that they keep slapping because it's pulsed. Bang, 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 and squirts out the white. Now, can we shoot that white into some kind of a capture device here? Almost like a solar receiver, because this is nothing more than electrons. Same thing you receive in a solar panel. So we need something here that can absorb all of that energy and squirt it down. Basically, it's just like having to go to a solar panel. Now, Rogran and Tyson are working on this right now. Rogran works with optical acceleration, concentration basically. And Tyson's just getting started. We're trying to all learn all this stuff. Nobody's going to do this if we don't do this. I've been for 10 years. And John Lincoln is the guy standing in the way as far as I'm concerned. I hate to be, vindictive like this, and I'm not. I'm not vindictive. I just want this known. But I'm telling you, you get to a point where you're frustrated as hell, and you feel like lashing out somehow. And this is my method, is to just show it and point fingers at the guy that's standing in the way, who is Don Lincoln. And he's spending our tax dollars. I mean, billions and billions. They're doing the deep underground neutrino experiment, where they've already spent over $1 billion, and I guess it's gone up to $3 billion, and they want more because they just can't do it. They're never going to do it. It's been done 10 years ago, and Don Lincoln is the guy that's just in the way of everything, and it's costing us. You work hard for your money. When I was working, I worked hard for my money. I don't want somebody incompetent like this. Or the other alternative is just you know, I don't want to be nasty, but nobody can be this incompetent to miss this. You cannot be this incompetent. It's impossible. So what is the alternative? You decide. What do you think it is? Is it about money? Is it about status? Is it about control? Is it about ego? Is it about, you know, self-interest above all else? That's the only thing I can think of. You know, also there's another possibility here. There's a lot of money here. Who controls who gets what? That I would like to have a congressional investigation about, because this is billions and billions and billions of dollars. They get nowhere. You could just, and also there's whistleblowers there now that are talking about how bad things are there. All right, see, whistleblower report reveals Fermilabs troubles. They're not going to get anywhere what they're doing, and they're just spending our money like crazy. Now, why? All right, I want you to understand, Fermilab is funded by you and me. We pay their bills. They are not doing their job, and I want this thing taken care of immediately. So I'm calling for a congressional investigation about what they're doing there, and why are they just wasting all this money and getting absolutely nothing for it, and denying something that is absolutely certain that could be looked at. There's the particles they found 10 years ago. And I showed this to Don Lincoln, and it was nothing but pushback, and not only from him, from everybody in the in physics. But primarily, he caused most of the trouble because he refused to look at it. And I would say, I think, you know, I try to contact everybody. The only thing I ever got back at some, I can't even remember, I guess I got anything back, but they always refer to the guy that's supposed to be the top guy, and he is supposed to be the top guy for neutrinos. So, you know, why don't you talk to Don Lincoln? You know, that type of thing. Of course, I'd say, well, he won't talk to me. Well, duh, you're an idiot. That's why. So I blame Don Lincoln for destroying science for the last 10 years and bilking the public coffers. This is billions and billions of dollars. This is not chump change, my friends. We don't have that kind of money to throw around. You know, I keep saying this is nothing more than a nuclear bomb blast, a subatomic bomb blast. And it is. At that Venturi, where the light comes in, bam! Now look at it, how close these packed are, pushing the black and the white ahead of it. The house was out here. The house just burnt up, burnt up, burnt up, burnt up, and all of a sudden the black came, boom, it went flying. These are the Whistler waves. Remember that? That's those. You would hear them way, way, way out here instantly. As soon as that went off, it would go, all this would come out way out here. You'd hear that. But then it would take a while for the black to come out. Then you get to whacked. All right. All right, Don Lincoln doesn't even know what gravity is. Nobody does. It can't be explained with the current theory. It says, according to Einstein, gravity is caused by curvature of space-time. Well, what the hell does that mean? It just means that everything falls to the Earth because it curves as it comes by the Earth. That's all it means. That doesn't explain anything. Space-time, a combination of three dimensions: space, length, width, height, fourth dimension of time. Well, it has nothing to do with it. It's a magnetic, basically, attraction to the Earth, which is the ground that absorbs the electrons. That's why it gets hot when the electrons hit it, because they are that white glowy particle that has energy, and when it whacks something, it heats it up. Simple as that. First of all, we know Einstein was completely wrong about light. First of all, light is a particle and a wave. The particle is way inside, and the wave is the magnetic field that pushes through everybody else's field. That's what makes the wave. Now, it can accelerate quite simply by using a Venturi. That's acceleration. If you don't understand that's acceleration, these are the kind of things. Is somebody talking in good faith and say, oh, that's not acceleration? That's what Don said. That's just refraction. That's just refraction. That's the end of it. Don't talk to me again. I said, no, I want to know, how can you not see that? Also, at the Venturi here, it breaks. The black breaks away from the white. These two particles that he was showing, the two particles I showed attached together. All right, here they are right here. These are his two particles. Here's light. I said, and I don't back off easily, but I don't get nasty either until I get to a point where I realize the guy's not being good in good faith. And of course, he blocked me from everything. He says, I'll never talk to you. You're a tinfoil hat guy, and embarrassment to science and all kinds of things. And I saw a video he did saying, I know about everything. He made a big joke out of the things I was talking about. No, he didn't say my name, but trust me, I know who he was talking about, because we were at odds at that time long ago. We still are. And as a matter of fact, I'm blocked, so he'll never know about this until you contact him on his email or something, answer one of his questions. Say, Don, why can't you see this? You're spending billions of our dollars. Can't you understand this? Competence is a little importance here. To be able to just say, forget about it, I don't want to talk to you, Roger Spur, because you have too much evidence to support your side of this. And we need to be making huge amounts of funding to keep our jobs, basically. I don't want to take anybody's job. I just want something for our money. Turn your research into making these Venturis and creating portable devices and, handheld things to carry around. I think this could be very easily converted into a handheld separator of electrons, because that's all you want to do, is create these electron showers. These are the showers. These are the sterile muons. And here they are right here. These are the muon neutrinos, the black ones. All right, they separate from the electron neutrinos, which turn into showers. That shower is supposed to increase the energy way up. Let me show you. And we did it. There's no question this is done. 100%, no question. And they separated here. That's fission. That's fusion. And this, my friends, is dark matter. All of these things were answered 10 years ago, which I tried to engage with Don, and every time I would ask him anything, and the most simple questions, he had no answers, so he would just say, oh, that's this. No, you're wrong. No, you're wrong. It's impossible. And that was the kind of answers I get. Can you explain to me why something... Well, here, let me show you something. Hold on. All right, the black ball I showed you is the muons, and in this I feel they're correct. Muons are elementary particles not thought to be made up of any simpler particles. That's the black one. And they do have a much greater mass than electrons. They say they're similar to electrons. They're glued to the electron, but they have a much greater mass, an electric charge of -1. Well, that's up in the air. Muons are unstable. No, that's not true. And have a mean life. Well, if they're sitting on by themselves, which is the one when they come back together with the white, we showed you, yes, I can go with that, 2.2 microseconds, which is much longer than many other subatomic particles. When muons decay, they almost always produce at least 3 particles. Well, no, that's not true at all. Muons don't decay. Muons don't decay. How could they say when muons decay? Muons are elementary particles, not thought to be made of any other simpler particle. What is the decay? Where did the decay come from? This is the thing. It's unbelievable. All right, here's one of the questions I asked Don. I said, Don, can you tell me what heat is made of? When he stopped, he was always just one or two words, basically. No, you're wrong, or it's this, or it's that, or it isn't, or boom, no. So I said, all right, what is heat made of? Can you explain to me what heat is made of? And he says, it's just molecules shaking. End of story. That was it. Case closed. I'm right and you're wrong. Forget about it. I said, okay, if they're shaking, would that make them gain weight? And I don't have to answer your questions. Well, because things do gain weight when they get hot. Now, this doesn't explain it at all. This is AI. Heat is made of thermal energy. Well, why? Kinetic energy of the atoms and molecules moving and colliding with each other. When the temperature of a substance increases, the atoms and molecules move faster and collide more, which produces thermal energy. Well, what is thermal energy? The total energy of these moving atoms and molecules is heat. No, heat is little tiny particles that are in excess. All right, this thing here should have 100 particles in it. It's got 200 particles in it. They don't want them. That's what's called heat. Extra particles, extra electrons. They vaporize back out into the atmosphere until everybody gets stabilized with the same number of electrons they're supposed to have. This is only supposed to have 100, but at this particular temperature, which is, let's say, 70 degrees. At 80 degrees, it's got 200. At 90 degrees, it's got 300. It's just the way it works. And then they flow back out. So it loses all those. Those are extra electrons. Everything here is made to make that stable. Well, what happens when you shine a light on there or you put a blowtorch on there? Well, it warms up. Oh, it's just shaking around. No, it isn't. It gets heavier. It actually gets heavier. The only thing that gets lighter when it heats up is gases, because they expand. So the same amount of material takes up a bigger space, they go up. This doesn't get bigger, it just gets hotter. As it gets hotter, it gets heavier. This is basically hilarious. Here's AI again. Temperature can affect weight in a few ways. Temperature-weight illusion. Temperature of an object can affect how heavy it seems. For example, a study found that people perceived objects as heavier when they were cold. They perceive it's just an illusion. Forget about it. It's just pareidolia. Okay, my friends, this is literally insanity. They're talking about heat. Now, heat in thermodynamics, heat is the thermal energy, that's just temperature, transferred between systems due to a temperature difference. Well, what causes that temperature difference? In normal use, heat sometimes refers to a thermal energy itself, the thermal energy. Well, what's the thermal energy made of? Thermal energy is the kinetic energy of vibrating and colliding atoms in a substance. So they say the same number of atoms, they're just bouncing around now for some unknown reason. They're starting to bounce around. It doesn't weigh more. Well, it does weigh more. Now, an example of formal versus informal usage may be attained from the right-hand photo over here, in which the metal bar is conducting heat from its hot end to its cold end. Yes. But if the metal bar is considered a thermodynamic system, then the energy flowing within the metal bar is called internal energy, not heat. That's just insanity. When you pump a whole ton of extra electrons in there, they just want to flow down through to where they're going to be accepted, which is the other end of the bar. It doesn't have all those extra electrons. Now, what happens around here is they just flow off into the air, and the air gets warmer. They're accepting a whole bunch more electrons. It's not just vibrating. This is insanity, absolute insanity. Okay, my friends, I am very sorry, but as you know, I am into virtually every area of science, and okay, my friends, I'm terribly sorry. I lost track of this because I'm into every area of science. I get a lot of different things happening all at the same time, so. Okay, my friends, very sorry. A lot of distractions. I'm going to probably go over this thing a couple more times, the same thing I went over before, but like I say, I'm into a lot of different areas of science, and I have a lot of different things that pop up. Anyway, okay, my friends, a lot of distractions, so I'm probably going to go over things again that I've already gone over. But as I remember it, light is made of the photons, and they just say they have no mass. See, they say photons are bundles of electromagnetic field that carry a specific amount of energy, and that's true. They have no mass, that is not true, or charge, that is not true. Because of this, they can travel at the speed of light. Well, the speed of light is all kinds of variable. The amount of energy a photon carries corresponds to its wavelength. That's true. The different colors of light have different wavelengths. That is true. For example, blue photons have more energy than red photons. That is true. And ultraviolet photons have more energy than infrared photons. That is true. All it is a spectrum. It's just right here. All right, these are just real radio waves way down there. Visible spectrum's up in here. Ultraviolet's up here. And then you get to what they call the ultraviolet catastrophe, where the energy increases and then all of a sudden it goes right down to zero. Because there's no more white particles left. There's no more energetic particles because it's spinning so fast. And these are the ones that kill you, the X-rays and the gamma rays, because they're just nothing more than the black particles. The ones that knock the house down. Okay, these are the muons. They're the black particles that I showed you, and they are also elementary particles, not thought to be made up of any simpler particles. All right, they're similar. I think I already talked about this, and they just have a very big atomic mass because that's where all the mass lies. The white particle is attached to it has no mass to speak of. As you saw, the house just burnt up, didn't move. This I found extremely interesting. They have a mean half-time. Muons are unstable by themselves. They will not stay by themselves. They want an electron to attach. And they have a mean lifetime of 2.2 microseconds, much longer than many other subatomic particles. When muons decay, they almost always produce at least 3 particles. Well, again, I remember going over this too. How can they decay if they're just the smallest elementary particle that exists? I just don't understand. Even decay doesn't always go downwards. They don't understand that either. It goes upwards. Isotopes go both ways because when you have a particle like that, an atom, okay, let's say we've got phosphorus. Phosphorus can decay down to silicon, yes, absolutely. But it can go up to sulfur. All that is they lose a few particles and they go downwards. Okay, so these go away and they go downwards. They want to get some more of these coming back so they can get to stability, which is at a certain number, a certain weight. Now, if they have extra ones somehow that got attached to here, that's decaying upwards, which means some more come in here. All decay is just a change. Decay is not necessarily decay. Decay you think of as rotting away, going down. And that's how they always say it. Decay is always, they get downward decay. No, it can go up too. All right, here's some more extremely basic questions. If I said phosphorus to you, what would you think it was? Like one atom of phosphorus, right? Well, there is a bunch of little electrons around it so that it can attach to something or that type of thing. Okay, but you would consider it to be a little ball like this. Well, guess what? It's not like that at all. It's a ball like this. And there's a zone of stability for phosphorus. Now, remember, this side is silicon and aluminum. That side is sulfur. All it means is there's more particles up here and less particles down here. And that is the zone of stability where the P is, phosphorus. So what are we looking at? This is all phosphorus, isotopes of phosphorus. Well, what is an isotope? It means it's not actually phosphorus. I'm not kidding you. Phosphorus is stable right there, okay? Stable. And what does it have? It has 31 particles. All right, 15 is what they consider to be protons, and the rest are all neutrons. That's just all nonsense. They can't account for them, so they give them little names. Now, so where we are is stable, is where we are. They're right there is stable. This one would be stable. Well, if we go down, you see this is the weight, 30, 29, 28, 27, 26. They're just taking more and more particles away. And another one, and another one, and another one. And it goes down, and it becomes less stable. Okay? So that would be what you consider a decay from stability. So, and that's how they look at it, a decay. It goes from stable downwards to silicon, right? I told you about that before. Phosphorus down to silicon, even all the way down to aluminum. That's the daughter isotope. A daughter isotope means the particle is given off after this thing decays. And the decay mode is, well, they just have decay modes. Half-life is how long will it exist in this particular configuration before it changes into its daughter isotope. And then you get up here almost, and even magnesium, it can go all the way down to magnesium. All right, you see this? It depends on how it decays, basically, under what conditions. But after you go above stable, it's all sulfur. You see the S? That's decay. That's the decay. That doesn't mean it went down. It means it went up. It went from stable up to sulfur. Now, then you take sulfur, which is the decay of the phosphorus, and sulfur can decay up again. And that one can decay up again. So I call it atomic bump. So it bumps right up the line. And that happens because of enzymes. And that happens because of biology. A lot of this is not understood. They can't account for any metals above iron. They say, well, they must have happened in a big bang and now all of a sudden they're everywhere. No. So much does not make sense, and everything I show has a physical component to it. I do material science. I don't do guesses and, making things up to keep them, control over the students. And they won't let the students talk about this stuff. You start talking about this, they'll fail you. All right, what else do we got here? All right, this is cold air sinks. Well, why do you think cold air sinks? That's another thing I asked Don. I asked him all kinds of stuff that he never answered. Well, cold air, you got a hot item. This is it right here. This is the hot item. Right above here, the Earth is down below me, which it is. If that was real hot compared to all of the other stuff in the room temperature is 70 degrees. That's 100 degrees. All right, what's going to happen? The heat is going to come off and come off into the air. But it's not going to, the heat rises. And it rises because it's heating molecules here to expand. When a molecule expands, it gets lighter. This will not expand. This stays the same size. So it gets actually heavier. Even though the heat is going up, this will go down. All right. Now, when you towards the Earth, this is gravity. Now, cold. If this gets colder, the cold air just falls off. This is the air falling off. This is the air rising up. All right. It just falls right off towards the Earth, and a cold one is less heavy than the hot. And the more electrons you pull out of a cold item, the more conductive it becomes. And I know this for a fact, 100% fact, because I worked on the first equipment to come in the country, and it came in working at 17 volts, the chips. And they were, because they could test them, and they ran fine at 17 volts in the factory. But when we started delivering them in a cold environment, the chips exploded, literally exploded, because they were down at 30, even some of them frozen. I had a bunch of guys working for me, and I was the field engineering manager for Victor Business Products, a Walter Kidder Corporation, when they started to really get into electronics. And they were one of the first ones to have a really high quality electronic equipment, and my job was to make sure the damn things worked. So we got them in, because they were the first ones. Basically, I think they might have even been the first ones to come into the country. And I got them in, and we set them all up in a shop and tested them out, took test tapes. You always put the test tape in with it so you can say to the customer, here, so I've been all checked out, here's the test tape, blah, blah, blah. So they put them in their cars at night. They're going to go deliver them in the morning. Now, we service all the big companies, Travelers and Aetna, and a lot of insurance companies and all that business. And they wanted these machines to do these things much faster than the old style adding machines, basically. These were really good, powerful equipment. But at 17 volts, and at 30 degrees or so, because in Connecticut it gets cold. So they delivered them, and as soon as they plugged them in, pow! And they said, well, I don't know, I was working at the shop. And they brought them all back, and sure enough, the chips, there's a flat chips back then, they had legs all coming down from about 100 legs from this big flat chip, and in the center there was a circle, and the circles were blown right off. And I said, wow. what's this all about? And I get hold of the factory, and they said, I don't know, they were working fine here. So I said, well, they're not working here. And I had all the equipment there I needed. So I set up the equipment to see what's the difference. Why would it blow up? Well, the resistance of the flow of electricity was so much more at 70 degrees, it would keep it from really rushing through there. There were so many extra electrons in there. I'm saying electrons are heat. They're in the wires just like they are here. So they're stopping the light, the electricity from coming through. They're holding it back. So at 17 volts, it's pushing, and it's coming through nice, no big problem. The chip handles it fine. But when you take all those electrons out, because it's cold, and I mean it was freezing, and then they plug it in, it goes right through there, no resistance basically. The lower you get, the more flow of electricity. Absolute zero means there's no electrons left in there. You get superconductivity. It just wants every electron you can put through. It's as simple as that. It's so basic, it's hard to believe. They don't understand this. There are extra particles in there that obstruct. So here's my position. Well, here's what happened with me. I set everything up on a bench. I tested out 70 degrees and what was the amperage, because the amperage is the key. The voltage stays the same, so 17 volts never change. How many electrons were flowing, that's the amperage. So I set up the amp gauge there. I had the equipment I needed. So I checked it at 70 degrees, and I think it was, let's just go round numbers. Let's say it was 1 amp. It was just nowhere near that, but let's say it was 1 amp. And then down at, I think we froze and put them in a refrigerator. I can't remember what we did. Yeah, I think that's what we did. And then I took it out, and it was down at, I think so we had 1 amp at 70 degrees. And I think we had 3 amps at 30 degrees, so like 3 times as much amperage. It just couldn't handle it. It came into these little tiny circuits, exploded right out. So they changed it down to 5 volts. Now everything basically runs on 5 volts. All the rest of the stuff ran at 17 volts. So I think they just decided, well, we use the same voltage for everything. Because it worked in the factory at 70 degrees, no problem. That's the kind of, and that's what, I was a field engineer. I love fixing stuff. As a matter of fact, I got to be honest with you, this is the funniest thing. My son, when he was a little tiny thing, he's only, I don't know, 6 years old, 5 years old, maybe even younger than that. We're in the hardware store or something, and I was buying something to fix something. And this little kid comes up to my son, they're looking at each other, and my son says, yeah, my name's Max, this is my dad, Roger, he's a fixer. It was the cutest thing I ever heard. Okay, I know we talked about the muons. Those are the black particles. The white particles are the electron neutrinos. These are muon neutrinos, electron neutrinos. There it is right there. Muon neutrino, electron neutrino. The black one attached to the white one. The black separates from the white. We saw it as photons quite clearly. Well, here they are, just before they explode here. That's the explosion where they split apart. This is where they're together as photons. And they will always be together. The black will never be apart from a white, except for what we did and for what CERN does, and they explode in Fermilab. Now, putting them through the Venturi was better than what they do. Again, I think I showed you this before, but when they hit them, they just go like this. Rarely do they do this. But when we go into the Venturi, there is no escape. They crush fields. All this is they're doing is crushing field to field. That's all they're doing. And that makes all the particles scatter. We have them crushing the fields into each other and only allowing the whites to spit through. There is nothing better than this. There is no better than this that you can get. Because we can focus it in to use this. Right now, these gigantic things that they're doing, it's just a huge, enormous waste of money, when we might be able to get almost free energy, portable, clean, safe. I don't know what else is better than this if it works, because all we want is that white. You see this? Everything verifies exactly what I'm saying. I said, how heavy is electricity? It says electricity is just a flow of electrons, the white particles. And these electrons do have mass. Right? They have to have something. But is an absurdly small amount. You really can't measure it, to be honest with you. As you saw, the house didn't move. It didn't move. Something had to be there. You know, you can't make that much energy with nothing. So something is there, but it is absurdly low. If you charge a car and it weighs 4,000 pounds and it's completely empty, but it weighs 4,000, you charge it all the way up to be full, it still weighs 4,000 pounds. You drive it until it's empty again, it still weighs 4,000 pounds. Doesn't matter. The electricity has virtually no effect on having an energy to move that sucker 500 miles. For gasoline to do that, you're talking 60, 70 pounds or more of energy that's in the form of weight. This has no weight at all. Electricity is, strictly speaking, just a flow of electrons. So it doesn't make sense to talk of it weighing anything, as it is an abstract quantity. And that's what Lincoln says, Don Lincoln. I agree with that. I can't see it moving anything. I didn't see it move the house. You didn't see it move the house. I don't see it having any mass, but it's got a hell of a lot of energy. That stuff will go right through you with a lightning bolt and explode you into a billion pieces. Okay, I think I talked about photons, but just to be sure, photons, they say, are the tiny particles made up of electromagnetic waves, are considered to be the smallest possible packet of electromagnetic energy. They have no mass, that is incorrect, or charge, that is incorrect. They travel at the speed of light in a vacuum. Well, there is no speed of light. I can accelerate light here on Earth, not even in a vacuum, so that's just nonsense. Photons are the force carrier for the electromagnetic force. That's okay. And represent the entire spectrum of electromagnetic radiation, including radio waves, gamma rays, and visible light. I agree with that as well. Those are particles that will bounce because they're two particles. Well, let me just be sure you understand what they look like. Now, they're talking about waves. They're not waves. They're spinning particles. All right? They're a particle just like this. And it spins through the air like that. Red ones spin slow. Spin, spin, spin. Green ones spin faster. Blue ones zip right through the air, and when they hit, they're much more energy when they spin faster. That's the difference of the energy of those three, the red, the green, and the blue. And I show that very, very clearly. All this is right, and they are all products or produce these, they call them waves, they're spinning particles. It's just the speed of the spin. That's all that is. This is spin slow. And it goes on. All right? To make it clear? All right, I know we went over the neutrinos, the muon and the electron neutrino. Two different pieces, not just one. Now don't forget, this is what physics, state of physics, because of Albert Einstein and these laws and rules and so forth. Space-time is warping of this and a time and the fourth dimension of this and that. And light can't accelerate, it goes one speed, nothing can stop it. Well, it's totally wrong. All right, you see this? You'd have to be insane to read this. But specifically, they're looking for the Higgs fields. And this is going beyond the standard model. Yes, because the standard model does not work. We show these Higgs fields in exquisite detail because we're working with the smallest particles. They just see big masses of fields. And, well, let me just show you that first, and then I'm going to show you how much nonsense they can make out of these laws and this CP violation. All right, let's see what we can look at first. Hold on. Okay, here you go. This is the Department of Energy. Hold on, my friends. Okay, my friends, this is the Department of Energy explaining the standard model of particle physics. And here's what they claim. I claim there's only two particles that exist. All of this is just reconfigurations of the white and the black particle. When you put those two together, they make a gluon. So this is a white and a black together, make a gluon. The gluon, two of them back together, make a photon. Case closed. If you divide the black and the white from each other, when they come back together, they will make a Higgs. It's not the other way around. They think the Higgs decays to this. It does not decay. It reforms if there is decay, which we broke the particles apart, so they had to come back together, and that's when you get the Higgs bosons, and boy did we get Higgs bosons. You want to see some Higgs bosons? There they are right there. This is the phone. This is the Samsung phone that took these pictures. It's right over here. Same phone, same. Hold on. Hold on, take it easy. I got it. See that? That's the same phone right there. Samsung. Now, and the same laser that did this. Now, these are from Rodney Warren. I have the same equipment here, and I did the same sort of stuff, but he was so good at it, and I had so many things going on that I let it go, and he spent literally thousands and thousands of hours. Finally, I never heard another word from him, and I don't blame him. I just hope he's okay. Anyway, Rod Warren is the guy that came up with this just by accident. When I saw what he was showing, I knew what he's showing. Those are Higgs fields. They're the same fields that they show from CERN. I had them somewhere around here, but I don't see them now. But we had them, and this is another thing. This was I sent to Don Lincoln 10 years ago. They made a black hole, the Russians. That's a black hole. The particles coming down forced the black into the center. That's in a vacuum chamber in space. And the Earth guys couldn't believe it when they sent the pictures down either. I sent him this, and I sent him all the information about the particles that we found, and I just started to ask him questions gently. I was trying to be nice. But then he started calling me names. And then, then it was... the gloves are off. And here's what they're doing. They're just smashing things to bits. We're down here in this particle. This is down in that particle range. And these little bits and pieces, we can see those little bitty pieces. Because we started with light. We didn't start with just something to make a big pile of debris. And that's what they see as a pile of debris. Now, I was in the Army in 1968, 72, and I was doing, service in Nike Hercules missile sites and so forth. And my theory was that the transfer of energy was from light into atomic vapor, which it is, and then it condenses, just like the vapor of water molecules in the air. Light condenses to make matter. And I had Rutherford's atom was wrong and so forth, and everything was based on that back at that time. And there's only two types of intermolecular forces, which is dipoles, and some of them are polar and some of them are non-polar, and I try to point out some of the differences. And I based the weight of my electron on Millikan's oil drop experiment, and for some reason I changed it to 1823, but as I saw back in my paper here, I have 1839, and 1840 was for a neutron, but it's 1840 electrons. Well, yes or no, I don't know. Light is an atomic dipole vapor. That's what I call it. Yes, light makes all matter, everything. Electron dipoles make light. Yes. Therefore, the universe is filled with matter as vapor. Yes. Therefore, no space vacuum. Therefore, light slows down as it comes through us. There's no vacuum in space. And they know that. There's absolutely no question about that. And they base the fact that light never slows down on the fact that there's no mass to light. And that's totally wrong, too. There's no question it's wrong. A Crookes radiometer, a kid's toy, can show that, and I have one here, and I play around with it all the time. But the crazy thing is, light drives the black that way, but light will actually pull the white towards it. If you have a Crookes, play around with it. The heat makes it work, cold makes it work. Everything is heat and cold, light. It's all particles. And these are the things that they don't understand. They don't understand heat, they don't understand light, they don't understand gravity, they don't understand dark matter, they don't understand what molecules are made out of, they don't understand isotopes, they don't understand decay upwards, they don't understand the heat that's surrounding the Earth at 3,000 degrees way out there at the ionosphere, where we're scrubbing through everything else in space. They don't understand. And why is that 3,000 degrees way out there? Well, it's because they're scrubbing. They don't take that into account. They don't even think about it for global warming. Same thing for the corona of the sun. They're going to spend some more billions of our dollars to go out and study the corona and why it's so hot. It's from scrubbing. It has its own atmosphere that's glued down to it, basically, and it scrubs through space as it spins. It's as simple as that. It's very discouraging, the people that are in charge of looking at things. Plus, Mars is saturated with the same biology as here on Earth. That's absolutely no question about that. I presented that 10 years ago to NASA when they went up with a Curiosity. Instantly, I knew what it was from studying the mud fossils. It's a mess with the educational system, and it's collapsing right now. Even NASA themselves, I think they did a thing saying like 40% of all private schools will be closing because they're just wrong. Even NASA says that. NASA is one of the wrongest of them all. Oh man, I think the academic system is just going to fold because almost everything that they're taught is wrong. If you're taught history, you just learn a bunch of nonsense. Chemistry's got to change quite a bit because of dipole electron flood theory. Physics is totally wrong. Anthropology, archaeology, totally wrong. Geology, totally wrong. All of those things are just not right. Now, if you learn how to do programming, well, that's a different story. If you learn how to build a house, how to maintain the roads, electronics, those things are material-based things. These other things are, let's explore this, let's think about that. Well, no, they don't think. Let's make up a bunch of stuff so we can get funds. That's what it's all come down to. It's about how much concocted stories you can come up with. And then maybe we can get some funding for that. And they've been doing that about my research. They've been getting funding to do the research I already did. And as a matter of fact, Yale got funded by NASA to do the research on the mud fossils. I contacted NASA, and they must have contacted Yale and says, "This guy right?" And Yale said, "Yeah, it's right, but he's a nutcase or something." I don't know what they said about me, or even they said anything about me. But I had reported all my stuff to Derek Briggs at Yale, and they wrote the paper about it. It's the exact same thing I said, only they put it back, the Triassic, at 540 million years. I put it at 3,500 years ago. Every single thing I have is on the surface of the Earth, not buried. It's just right there. How do they explain that? Well, I don't have to explain anything. Yes, you do. If you're a fiduciary to your students, you are there working in their best interest, and they put all their trust in you, and they give you a bunch of money to guide them, putting their faith and trust in you as a real searcher for truth to help them. Instead, it's just the opposite. They end up being the dictator to the students and saying, "If you don't say what I say, I'll fail you and I'll ruin your life." And basically, that's how do you see it? Think about what's happening. They say, "Pay me so that I can help you. And I put your faith in me, put your trust in me, give me money, and I will help you to learn and understand what everything is about, and it'll be all truthful, and you'll be happy, and your life will be wonderful." Well, we're finding out that's just not the case, and I have so many examples of it. It's really discouraging. So we need to change it. And I heard there's a guy given, like, I think he put up $100 million for a new school, online Ivy League university. I would like to be part of that. I would at least like to be able to comment on what they are teaching. And that's what a university is about. A university is about a discussion, a forum, a place where you can go and exchange ideas and develop ideas based on different things. Because I learn from every day. I learn from somebody every single day, 100% every single day. I get something from somebody that I didn't know about, or it helps me in my research. Let me put it that way. It's not every day it's a brand new thing, but every day it's something that either reinforces me or maybe change my attitude towards something. It depends. Where's the evidence? Show me the material evidence. That's my realm. It's material evidence, as you can see. Now here's what they show for their Higgs fields at CERN, or this was CERN, Large Hadron Collider. They just get debris. They smash these things together and they see these big fields come out. But these are all the particles they see. It's a particle zoo. They take literally years and years and hundreds of people digging through that to find these particles, which are these two particles. They found them. They finally said, yep, these are the two particles. We found enough of them that we feel convinced these are the smallest two particles that exist. There they are. Now, why Don Lincoln will not engage is very, very hard to understand, and because he is a public official, taking public funds, spending billions and billions of our hard-earned money. And I'm telling you, money does not come easily now. And they just went up on our electric rates here in Connecticut. So all of a sudden, bam, I think it's like a 20-something% right on top. And if we could get free electricity out of this is just insanity. It's been 10 years denying to even look at this. And all electricity is that white part right there, these electron showers. That's what you need for electricity. And that's what they say. Electron neutrinos turn into electron showers. Done it. Why is this not looked at? And who is standing in the way is Don Lincoln. All right, don't forget, all of these are just, simulations. These are the simulations they're showing. They're so proud of, these Higgs fields. Well, these are not simulations. These are the real things. And this was taken with this cell phone, looking straight into the Venturi. And these are the Higgs fields coming at us. I call it Higgs on the move. Now, the other thing you want to see is this is a red laser. Starts red, should end red. It shouldn't increase. However, it does. Because this field and this field pinched this one in the center, pinched it and elongated it. It's coming right back down, and it turned back down to here, and then it actually turned orange, which is not quite down to red. So it's tapering down. Anyway, the stuff that Rodney did was just beyond belief, actually, to my way of thinking. All right, I'm going to see if I can make sense of this to you. We accelerated the light. The light started out like this, like a basketball coming through the air, and a particle right in the center. And the field creates the wave. So we have a wave, particle. That's it right there. Now, all of these particles are pushing back, so they're glowing just a little bit. This one's glowing a lot because it has to push everybody out of the way. So each one of these glows a little bit, and this glows a lot. That's that interaction. Now, it's just beginning to accelerate. You wouldn't even see this here. You wouldn't see that at all. Light just simply flows through the air until it's accelerated. And it is now becoming accelerated. So as that acceleration happens, here's what happens. The particle, which was back here, starts to get pulled right out of the wave because it has to, because of a Venturi. It's a well-known effect. A Venturi is an accelerator. And it is literally pulling that particle, which you have seen before, the black and white particles, out of the wave, ahead of the magnetic field. Just like a jet fighter pulling itself out of its own you know, right straightforward is breaking the sound barrier. This is like breaking the light barrier, and it comes out here as a particle. Here it shows up as a particle because it's being pushed back at, and that's the only reason. See here, 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 here. Those were all fields as well, coming this way, just like this is coming this way. You didn't see them. You never would have saw those. Just not even there, unless they either hit the wall and bounce back, which is the normal case for light. It hits something and bounces back. Otherwise, it's dark. So the light hits something and bounces back. Well, here, it thinks it hit a wall. All these think they hit a wall because this thing is shooting back energy so violently that it creates that interaction right there, and that interaction is where the particle shows up. Right there is where the particle shows up, and here's the particle actually showing up. All right, it's coming down. It's coming down as a photon, as a neutrino. All right, it's not fully fledged photon yet, and then they tip up sideways. Now, don't forget they're coming here too. Remember, I showed you those other fields that were those half of fields that were lit up? That right here is where the bounce back comes and they light up here. These fields are starting to push back and you can see them glowing around the edges. Let's take it one step at a time. There's the particle coming in. And it's getting faster and faster, and then it bounces back and hits ones that are bouncing. So it thinks it hit a wall. All right, I hope that makes sense to you. Because from here, the radiation is backwards. So it's like hitting head-on light. This is coming this way, this is coming back, and it's just a brilliant glow because it's like almost like doubling the speed of light or something. One's hitting head-on. It's like we're doing what CERN is doing, but with light. All right, so when it hit here, it bounced back, and this was hitting this one coming back. But the whole thing is one gigantic reverse electromagnetic field, and it is identical to what would happen in an atomic bomb. You see those fields? Remember the atomic bomb? I don't remember if I showed you that, but if I did, fine. If I didn't, well, that's what happens. But right here is the key to the whole thing. This is where it starts accelerating. And it comes down, and right here, it hits, and they all hit at the same time, basically. You see? Because of this big field that's expanding like an atomic bomb. And it literally is a subatomic bomb. That's fission, that's fusion. And they say it's 2.2 microseconds or milliseconds, something like that, before this one joins back to the black. And that could be, that could be. This just validates my claim that light spins. It's just like a drill bit. You talk to a machinist, you say, yeah, that's the tip of a drill. And here it is here, going just like this. But there was more than one. There's a ton of them. They're all over the place coming down here. Remember I showed you all around the edges? They're all over. But they're spinning. So what happens is when it gets through the venturi, the white does not want to be next to any other white. So they set up these, what they call interference patterns. They're push to shove, push to shove, push to shove, and they set up in a circular form like this because they're spinning. Some spin way off this way, some spin this way, some spin that way, some spin so forth. That's what you get. All right, that shows and proves that light spins. This shows that light splits and the black can push the white. There it is right there. This is like a tuned venturi that's tuned to let a little black through, but not a whole lot. And when that black comes through, it just pushes all the white that has been accumulated in front of it into a wave formation. And this is the Whistler waves, and that is the really high energy waves that makes the extreme push. And remember the house? Just no movement, just floating up. There's almost no weight here. I can't explain it. Now, I'm positive I showed you that, but if I didn't, there it is. That's the green particle, exactly the same as the red. And This is the green and the red going at the same time through the same venturi. It's like a high up venturi, one coming here, one coming lower. The red one just get pushed out of the way. The green came through and reconcussed out here. So we know there's an extreme difference in energy, one way or the other, whether it's spinning faster or moving faster or whatever. But the green is the same particle, identical particle. You see that one, and I showed you the other one, same thing, no difference whatsoever. So now, here's what I'd like to have Don Lincoln explain to me. Explain this. We have all of these particles, we can see them coming out in Higgs fields. I've never seen one other thing than the Higgs, except one time, and here it is. This is the particle. You see that? That's a piece of one of these light disks. Now, what is it exactly? I can't tell you, but it's not a complete, well, I believe this is a reverse spinner. And the reason I think this is a reverse, like an anti-spin, is because of another shot Rodney sent me. This is, again, all Rodney. He must have spent, I can't even imagine the time. I have literally hundreds and hundreds and hundreds of pictures that I still have, and I threw away thousands probably. He was so excellent at trying to do this and did such a magnificent job. It was a tragedy to let this go to waste, but that's what happens. All right, now I can't guarantee you this is a fact, and again, I can't get through to Rodney anymore, but I believe this picture goes with the other one I just showed you with the antiparticle. And at this point, it's showing this particle glowing like that, and it's the only one it is, and you can see that little trailing. See it? Why is that happening? What's going on with that? All right, I know you can see it. It's got energy. Now, I believe, I believe right after that, it hit another field and stripped the particle off the field. All right, now don't forget, this is looking straight into the venturi, and we see this white particle. We're looking straight into the venturi. All of that white stuff's coming out of us. And as they reform, they turn into these Higgs fields. And see these little spritzes? When the spritzes seem to hit, and they hit a dark particle, it appears, they start to spin. Well, this was spinning backwards. I think it was gathering its field in rather than spinning it out, something like that. Now, so then I believe it is that particle. But again, I can't be positive, and I can't get through to Rodney. But I believe that is that particle. And what's happening, it's spinning this direction. These are spinning this direction. Normal direction is spinning this way. This one's spinning that direction. Now, what would happen if this? And I believe that the outside part is where the particle exists. I think. Now, this underneath one here is coming around this way. This one's coming this way. The interaction of this one coming this way and this one coming against it is going to strip this particle off. I would think. I think that's what's going on there. It like ripped it away as this one starts spinning this way, grabbed a hold of this one as it was coming this way and just twisted it off. And here it is spinning. Now, that white means there's a lot of energy here, because the energy is the bend, moving that. It's got to be the particle. I can't see any other possibility. And it is reforming into whatever that is. You see that? And I think this has some form of a pattern to it. And I believe it is that white particle, which was a little glowier than everything else. And when it hit here, and now it's just stripped off. So at this point, the field pretty much is gone. The field no longer exists as this is ripped off. That's what I'm seeing. Now, if I'm wrong, I'd like to know. And what does Don Lincoln think about this? That's not interference. And it was very, very discouraging, because everything I asked was just completely dismissed, and the arrogance, you could cut it with a knife, that I was an embarrassment, and I was a tinfoil hat guy, and all kinds of things, you know. And anyway, it was a bad. I tried to be as nice as I could be, but then I started getting nasty too. So, and then he said, "Well, you're being nasty to me," and I said, "Well, yeah, yes, I am." And so he blocked me. That's all right, because this is going to be heard, and it's not going to be pleasant for Don. I would think, to know that this would have been able to be done 10 years ago, and all this stuff was so obvious that for him to say, "Wow, I just never realized." No, because he realized. Trust me, I didn't back off easily, and I still, to this very day, it's just like last week he finally blocked me again. And because I just kept asking questions. I said, I'm just going to keep asking this guy questions. And finally, when he said, I'm not going to ever answer a question you ask, you're just wasting your time. And I said, well, I'm telling you what, if you don't start answering my questions, there will be a congressional investigation as into your behavior and your misuse of public funds and abuse of public trust. And he blocked me. So here we are. All right, this is just too cool. You know, I think I might have showed you this already, but Rogran is a guy over in Italy, and he's doing some research on the light, and he's looking into what everybody else has to say, which is the way to do it, find out what everybody has to say. So he sends me this, which blew me away. This is Whistleblower Report Reveals Fermilabs Trolls. Now, Sabine Hoffenfelder is a very, very respected physicist, and she realizes that we're being taken to the cleaners, and the academics don't care. So she's stepping up. I was really surprised to see her make a turnaround. This was, I don't know, 6 months ago. She started to really turn around to say, this isn't right. It has come to this. Listen to this. Fermilab is doomed without management overhaul, claims everybody that's there. They're whistleblowers. They're saying, here, we got all kinds of problems. They got sexual abuse. They got all kinds of things going on. And they're so over budget, and it's just like money's no objects, just keep throwing more at it. And they've run out of funding for this neutrino experiment. It's 10 years ago they found it. And they've spent billions and billions of dollars. Hold on a second. You see this? This just came out about the whistleblower. All right, they have whistleblowers that are talking about sexual abuse. In addition to this, Fermilab aims to become a world center in neutrino physics. It was found 10 years ago. It is the host of multi-billion-dollar deep underground neutrino experiment called DUNE, now under construction, way behind, and still they ran out of money. The project has suffered delays, and in 2022, Journal Science and Scientific American each published articles describing the project as troubled. Yes, it's very troubled, and they are spending our money in these troubled waters. This is absolute insanity. We have already found these neutrinos, and this is what it's all about. This is deep underground neutrino experiment. Proved far more expensive originally estimated in 2014 when they were originally going to do this. Research is expected, and now that's when 2015 or so, when I'm talking to Don Lincoln, they could have changed their mind and looked a little deeper into this. Instead of spending, expected cost was $1.9 billion. Not is supposed to be completed in 2028. The cost has grown to $3.2 billion, and that's not for the whole project. They're just getting started. They're saying that the budget already stretched near bursting. This U.S. particle cost ballooning, and this is from Fermilab. These are the ones. The DUNE project, overseen by Fermilab, has suffered delays to its schedule and growth of cost from less than $2 billion to more than $3 billion. And it goes on and on and on. And they have already found these particles. These are the particles, and there they are right there. And we split them apart, creating muon neutrinos and electron neutrinos and electron showers, which is the holy grail of this whole project. It was done 10 years ago, and if not for Don Lincoln, this would have been looked at in much more detail. It's never been looked at. Never, and I've been assaulted for asking questions, saying, Don, can you please explain this, please? And I figured sooner or later he'd see that there was evidence that I was supporting about heat and light and, all of that stuff. And, how can you miss this? These are his particles. These are ours. They do exactly what he says. I showed you how the white has no mass and the black has all the mass. It's just incredible for my mind to be able to accept this. And people just say, oh, just leave him alone, just let him do what he's doing. No, absolutely not. That's not the way I work things, my friends. And I told him, I said, we're going to have a congressional investigation about this. This is not right. And they're under assault for sexual misconduct and all kinds of things. So, Fermilab, time to make some big changes. And they said it's got to be some big changes made in the management. He's up there in the management, and he's the impediment to science. He's a senior researcher and the mouthpiece for Fermilab. The only way to get past this is to get him out of there. Get somebody in there that cares. All right? That's all I can say. If he was doing his job, that's fine. If he looked into what I'm showing, that's fine. But when I have evidence and it's unknown to anybody, because the person that should be looking at that evidence, wait, you see this. I show physical material evidence, experiments, and back it up with theory that supports basically everything. And I'm not completely away from Don Lincoln's particles. He's showing exact identical particles that I'm showing, only we see them in their really uncomplicatedness, because we're only working with light. They're working with huge particles. They just make a mess. Now, when I show my stuff, there's, that can't be because you violate something. You violate this law, that law, this law. You can't go faster than the speed of light. You can't go slower, all kinds of things. And listen to this. This is the CP violation. Now, I can't remember who brought this up, but they're talking about the standard model, and they can't do that because of the CP violation. What does that mean? And so I started trying to look into it. I can't figure out what the hell they're talking about, but here's what happens. If you want to read this, God, good for you. And this is all about symmetry, and there's an experimental statuses. They don't know what the electron's made out of in the first place. So how are they going to make these violations and so forth? They don't even know what they're doing to start with. This is the CP violation in the standard model, and And look at this. I'm going to tell you, I did a lot of this stuff. And it is 100% nonsense, absolute gibberish nonsense. If you think you're going to get anything from studying that stuff, you are lost, my friends. Trust me. I spoke up, and of course I was just basically banished. So I went about my life. But now here I have evidence to support myself with these actual light experiments, showing the same particles Don Lincoln. Having him reject this, incompetence is no you can't. It's just impossible to miss this. No matter how incompetent you are, he should have some kind of level of abilities. Open mind, absolutely not. But when you're presented with this kind of evidence and you still maintain for 10 years, and then, arrogantly, you could cut it with a knife, my friends. And he is spending our money like water. So what I'm going to ask you to do is to contact your public representatives, congressmen, senators, and so forth. I'd like to see an investigation done. I know they're going to have one probably for the sexual abuse that they're having there. So I'd like to throw this on the fire, because this is even worse. They wouldn't have to deal with the sexual abuse if they were doing their jobs in the first place. It sounds to me like it's just a playground over there. All right, they got all kinds of problems. It looks like at Fermilab. They got sexual abuse, people carrying guns around, chaotic finances. I don't know who gets the bids and how they're awarded and so forth. It's a mess. It's a total mess. Fermilab is going down. It's a hostile work environment. The time to act is now, yes. And the time to act is to change the whole focus there from what they're doing down to dipole electron flood theory. Just take a look at it. If it works, it works. We found a neutrinos 10 years ago. I showed you this in so much detail, it can't be shown any more detailed. And if Don Lincoln misses that, and he's running this agency, that is a tragedy. Putting billions of dollars in the hands of somebody that just barely has... Trust me, he is not the guy for this job. We need somebody that's willing to look and understand what's put in front of him instead of being too smart for his own britches. And by the way, calling me all the things he called me, that's not... Well, let me just show you something. I have credentials. He has credentials. Well, nobody's going to see mine. They always hear about he's so smart and all that. Well, here I am right here. This was, oh, that's the wrong one. But this was, I went in 1968, right when the Tet Offensive started. And that was I went in February 12th, 1968. And I was E5 in September of 68. That's only, what, 7 months from the time I entered the Army till I got E5. Usually that takes years. I was a Spec 5. I went up going to Alaska, but I had an extremely high IQ, and they took advantage of that. All right, so this is my release form, and here's my GT. GT 139, that's General Technical. This is me. Now here's what it says about the Army General Technical. Has a long history, runs parallel with research, means for attempting the assessment of intelligence or other abilities. This is truly intelligence. This isn't knowing, you know, some special thing in history or whatever they can feed into your mind. This is working with gears and wires and electricity and all, you know. This is technical stuff. And if you scored above 136 or higher prior to 1980, which was mine was in 1970, 68, Mensa will accept the results of being in the top in the 98th percentile. Mine was 139. So 136, you're in the 98th. 139 means you're over 100. So, Don, everything you have done is against science and against the American people and against humanity in general. If we got to fix this environment. We got to get some energy produced, not the way you guys are doing it. And this has strictly been, as far as I'm concerned, you know, to hide from me, because I have the evidence to show that you already did this. I was trying to give you the credit for it. All I was doing was coming to you to say, yeah, Don, you found him, everything's good, let's get together and talk. No. It was nothing but insults, and to this very day. So, I don't think I'm a tinfoil hat guy, and I don't think I am the embarrassment to science. I think you might as well look in the mirror there, my friend, and I got a feeling, I'm hoping that the Congress or the Senate, somebody's going to take a look at this and say, this is insanity. We're giving this guy gobs of money. He's got to go. He's got to go. He's the problem. He's not the solution. All right, I told Don, I said, Don, we either engage or I'm going to go this route, and I do not back down easily. And this is it. All right, I love you all, and I'm hoping for the best. Contact your Congress people and tell them Fermilab's out of control here. They don't pay attention to what they should. They're not working for our interests, they're working for their own interests. And it sounds like this is a playground. I don't know, maybe it is, maybe it isn't. But we need to have that looked at. Get the Congress to take a look at this. This is our money. This is billions of dollars. Every billion is 1,000 million. And they're at 3 billion right now for this Dune crazy thing. They already found this stuff 10 years ago. 3 billion is $3,000 million. We could use that. We could use that for other things. Anyway, I love you all. Very long today, but I'm going to make some little shorties about the different things. But as far as I'm concerned, Fermilab is standing in the way of humanity. Of humanity, not just standing in the way of science. This is humanity. We need something done right away. This energy, and they're never going to get it there. That's a fact, as far as I'm concerned. All right, thank you. Bye. Now this is Lawrence Livermore, and their experiment sets new record in search of dark matter. And again, I believe I have found that dark matter. And they're talking about a bunch of different things, the new leading candidates for this dark matter. They still don't know what it is now. I did leave a message for Ian Stark on her phone, and I'm hoping she'll call back. And this just came out August 26, 2024. So they're still looking for this dark matter. Now, I think I showed you, or I will show you, that the increase in energy from the photons from the low energy showers down here to the high energy electron showers. These are high energy electron showers. High energy electron showers. Now, these are the muons. They don't go through, they back off. Now, this is Lawrence Livermore, I believe. And again, this is what we did here. The black ones back off, the white ones shower up. And that's what we did here. The black ones back off, and the white ones shower like crazy. I showed it a bazillion times. And this is what upsets me, because we should be able to get free energy and be able to carry it around in something like this, if it works. But it's something very simple to test out. No matter what I do, I'm going to be ignored, so I'm not going to do anymore. After 10 years being ignored, somebody's going to have to step up. That's all it is. I can't do this anymore. I cannot continue on doing this. I have showed that we created the electron showers. That is no question whatsoever, 100% certainty. Zero question that that's wrong. We created fission, 100% certainty. They came back together here. That's fusion, 100% certainty. This is dark matter. As far as I'm concerned, 100% certainty. They are the muons, and they are sterile, 100% certainty. These are the electron showers, and that is all by itself creating these extremely high energy showers. That is also extremely certain, because luminosity equates to energy. You know, the higher the luminosity, the higher the energy. And they show it here. We're getting a higher luminosity, creating extremely things. And this electron flood theory is, dipole electron flood theory is my theory. I've had it for many, many years. And now I can prove it. And it's still, proof means nothing anymore. Nobody will talk because they're afraid to speak up, and it might endanger their jobs. But here we need this energy of these neutrinos, a few hundred gigavolts, electron volts, that's billions, to a few trillions. They come in at millions. That's an absolutely incredible increase. Why can't we take advantage of this, or at least try? You know, I say, oh, why don't you just go ahead and do it? Why don't you just go ahead and do it? No, I'm not going to go ahead and do it. Somebody should take the interest in this, the people that we've been paying to try to do this for us. And these are the ones that refuse, and it's Don Lincoln specifically. All right, I'm laying this on his doorstep. And he knows, I told him, I said, if you don't start talking to me, I'm going to ask for a congressional investigation. And that's what I am asking for. All right, look at what they're doing here. This is called phaser. And this is a forward search experiment designed to search for light and extremely weakly interacting particles. The existence of such new particles is predicted by many models beyond the standard model, which is my model, that attempt to solve some of the biggest puzzles in physics, like gravity, and also dark matter, which mine solves both of those, and the origin of neutrinos. Mine solves that too, because those are just split up light particles. and the imbalance between matter and antimatter in the present day universe. And I see that there is an imbalance between the dark particles and the white particles. There seems to be more dark than there is white. I can't explain that, but I do know they come apart, so why shouldn't there be? All right, this is why I'm so upset. This is electron showers. These are the electron showers from the electron neutrinos. From the muon, neutrinos go on their own, the black ball. These are the showers. These showers increase the energy potential exponentially. Watch this. All right, this is the physics of electron showers. Now this is from, I think, from Lawrence Livermore. But anyway, they use proton-proton collisions. They make all kinds of little particles. Then they have to do something else. Then they get all neutrinos. Then they eventually get down to where we started with electrons and muons. Now listen to this. Energy of neutrinos interacting with this phasor go from a few 100 billion electron volts to a few trillion electron volts. There is extreme high energy as it enters, and the white particles go through and increase to extremely high energy. The black particles stay back, the muons. And they show this very clearly. And the energy you get is staggering. The amount of energy you get from this white is staggering. And there should be no reason we can't do something here to harvest that white. To rip the white away from the black normally is just almost, it takes literally tons of pull to pull that white off to generate electricity. This, we're not doing anything. We're just shooting it in there, and the white is being stripped off by itself because of the tuning of the Venturi. This is big. It at least has to be looked at. And to have Don Lincoln stand against this for 10 years, the planet's being destroyed. All right, I suppose that's my last word on this, but I just can't believe we can't get anywhere on this, and they're doing all this crazy nonsense stuff. I showed him this particle right here. That was out in space. That's how we first tried to hook up with Don. And then I showed we found his particles. It was so obvious. It's just unbelievable. So he can't deny that he's seen them. He knows that he's seen them. He can only say that either he's just so incompetent, he just doesn't understand. And I find that very difficult to believe. He doesn't seem like a stupid guy. But I don't know. If he can't understand this, how is he going to explain that? What is the alternative? I don't know. Anyway, I love you all. We need to stop this. This money is just being wasted away like never, and they just keep asking for more and more and keep doing more and more insane things. They're building huge things hundreds of meters below the Earth because we don't want anything interfering with these neutrinos. They're everywhere. They're everywhere. If anybody there is a physicist who wants to contact me and dispute what I am saying, that is what I want. I want some discussion, I want some interaction, and I want you guys to go against me. I don't want to just be left silent somewhere in the woods, which is the case. I'm not allowed to publish. I'm blocked from virtually everywhere. Don's got me blocked. Whatever I say, it's just inconsequential. So I'm asking for a congressional investigation so we get our money out of this. It's insanity. Literal insanity. Once again, I still love you all. Bye.